All right, this time we're going to be talking about transformations of functions. This is a pretty important concept. We're going to see it again and again and again throughout this course. And if you go on into trigonometry, you're going to see it again there. So we're going to look at graphing functions with horizontal and vertical shifts, so up, down, left to right, reflections over the x or the y-axis, vertical stretches, horizontal stretches, or compressions, talk about even and odd functions, and then we're going to combine all those transformations into one. So we're starting out talking really quickly about symmetry. So what does it mean for a graph to be symmetric? And most people say, it's like mirror image, right? And that is correct, but that's only one of the two kinds of symmetry. And we can look at this bat symbol here, right? Batman symbol. We can say, oh yeah, it's symmetric with respect to a vertical axis, probably the y-axis, right? It is not symmetric, with respect to the x-axis, because the top and the bottom are not mirror images of each other, but the left and the right sides are. So symmetric with respect to an axis means basically you can fold your graph along some axis, x-axis, y-axis, the line x equals 3, whatever, and the graph will lie on top of itself. So we say it's reflected across the axis. So if we do this with the x-axis, right, we've got some point x comma y, and if we're reflected across the x-axis, then that means we also have the point x comma negative y on our graph. Pretty straightforward. On the y-axis, kind of, pretty much the same story. We take that point xy, any x point y, any point xy, we reflect over the y-axis, and we're going to get the point negative x, right? Opposite x location, but the same y location. So that's our symmetric with respect to an axis. The other kind we have, we can also have, of course, symmetry about lines, x equals 4, x equals 3, whatever. We don't normally go too much into that in this class. Symmetric, so here's just a picture, the same thing I was just showing you, right? Only we've got a specific point this time. If we've got the point 5 comma 3 and we're symmetric with respect to the x-axis, so that means if we fold it along the x-axis, all the points are going to line up on each other. Yes, so this point 5, 3 is going to end up on top of the point 5, negative 3. And same story with the y-axis. This time, if we were to fold this graph along the y-axis, the graph would lie on top of each other, and our point here, 3, 4, would lie on top of the point negative 3, 4. So fairly straightforward. Our second type of symmetry is with respect to the origin. Let me see here. There we go. So this one's a little harder. This is if we rotate a graph 180 degrees about the origin and it ends up lying on top of itself, right? So like, let's say I've got this graph, which is x cubed, and I've got whatever this point is, x comma y. If I were to rotate this graph, imagine in your head rotating it 180 degrees, we're going to get that same point on the graph, but negative x, negative y. So that's our guidance here. For every point xy on the graph, the point negative x, negative y is also on the graph. So here we go. So there's our example here. Here's our cubic. We've got the point 2, 8 on the graph, but negative 2, negative 8 is also on the graph. Now we can look at this in GeoGebra. Let's see, start the calculator. And so we'll do this. We'll do y equals x cubed. And I'm going to put the point 0, 0 on here. I'm going to try to. There we go. Okay, so under tools, you don't have to know how to do this because honestly, sometimes I don't know where they are at. We can rotate. Let's see, where is it? Okay, I had to keep going more and more and down and keep scrolling down, but we have the option here to rotate around a point. And so you're going to select the object to rotate. So that's going to be our graph. And the center point. And then it's going to pop up and say, hey, how far do you want to rotate? So let's rotate it only for 90 degrees. And you can see, hey, we got a new one there, right? But let's change that. Let me go back here. We're going to turn off this new one. Going to go back to our tools. We're going to do rotate about a point. We're going to select our x cubed. We're going to select our point. We're going to say 180 degrees. And you can see absolutely nothing changed about our graph. It looks exactly the same. It's sitting on top of each other. This graph is symmetric about the origin. One of the older versions of GeoGebra, you could actually like drag it and it would render the graph as you rotated around the point. It was really nice. It doesn't seem to let you do that anymore though, at least not that I can figure out. So that's about our symmetry. So this is a good place to stop, and we will talk next time about even and odd functions.